mapping diagrams. So let's assume that we have two sets, set A and set B. And the question is how I'm gonna get set B from set A. So set A consists of 4 elements, so -3, 1, 4, 6. So how I'm gonna use set A to get set B. So if I tell you we're gonna add 3 to each element in set A. So -3 plus 3 is 0. 1 plus 3 is 4. 4 plus 3 is 7. 6 plus 3 is 9. So we are mapping set A to set B by adding 3 to each element in set A. So -3 is or -3 plus 3 is 0. 1 plus 3 is 4. 4 plus 3 is 7. And 6 plus 3 is 9. So every and each element in set A is mapped to an element in set B. So -3 is mapped to 0. 1 is mapped to 4. 4 is mapped to 7. And 6 is mapped to 9. So I can say that set A consisting of -3, 1, 4, 6 is the domain, and the domain is the range or it's the set of values of x, while 0, 4, 7 and 9 is the range, which is the values of y. So one-to-one and many-to-one functions. So let's begin with one-to-one functions. So if the first set is made up of 2, 3 and -1, while the second set has 4, 10 and -2. 2 is mapped to 4, 3 is mapped to -2, and -1 is mapped to 10. Now, why this function is called one-to-one function? Because each element in the first set is mapped to only one element in the second set. So that's why it's called one-to-one. So one element to one element. Now, many-to-one functions, so if I have again the same numbers, so 2, 3, -1, 4, 10 and 2. 2 is mapped to 4, 3 is mapped to 4, and -1 is mapped to 2. Now this is a many-to-one function because more than one element in the first set is mapped to the same element in the second set. So 2 in the first set is mapped to 4, while 3 in the first set is mapped to 4 as well. So more than one element or many elements in the first set is mapped to the same element in the second set. So that's why it's called many-to-one function. So an example, it says, given that the function f of x equals 2x squared plus 3, find in part A f of 2 and in part B the value of A such that f of A equals 35. Now f of 2 means I have to substitute 2 into the function f of x. So f of 2 equals 2. 2 times 2 squared plus 3. Now 2 times 2 squared is the same as 2 times 4 plus 3, which is equal to 8 plus 3, and the answer is 11. Now, in part B, I need to substitute a into the function f of x and equate the function to 35. So f of a equals 35, so 2a squared plus 3 equals 35. So I'm moving 3 to the right hand side, so 2a squared equals 32 over 2 and here over 2. So a squared is equal to 16. So what's a? A is the square root of 16, which is equal to 4 and negative 4. So 4 and negative 4 is the answer to part B. Part C of the question, I have to find the range of the function. So I have to find the values of y for the function in question. So our function is f of x equals to 2x squared plus 3. So let's do a table of values for x and y. So when x is 0, y is 3. When x is 1, y is 5. And when x is negative 1, y is 5 as well. So now let's do a sketch for the function 2x squared plus 3. So this is the x-axis and this is the y-axis. Now our function looks like that. So this is our function. Now what's the range of the values of y? So when x is 0, y is 3. So this point is 0 on the x and 3 on the y. And all the values of y on the function is greater than 3. So the minimum value of y for this function is 3. So if I want to find the range is equal to, so the range of values of y is greater than or equal to 3. So the minimum value of y is 3 and the values of y starts increasing. So it's greater than or equal to 3.